不要动小家鱼，好吧？不能吃蟑螂。
Hey, Jawad.
Hey, Anu. Hey, everyone.
So hopefully we get Mike Bartley on first. We should go with him first, I think, right?
That's what he wanted. Yes.
It is an odd time for him, so.
Ah.
Hi.
Oh, there's Mike.
Hi, and
Yes.
hi. Sorry, yeah, I had the wrong link for a little while, but I'm
He managed to get in.
yeah, good. Yeah.
Yeah. We'll wait for another minute or two. That's when we get some critical mass.
Okay. Do you want me to try and share my screen just to make
Yeah,
sure?
that might be a good test.
Yeah. So what I'll do is I'll run people through the document and based on just to get some initial feedback, and then one of the key things obviously we're trying to do is get folks to go through the document themselves, give some comments, but also maybe get some contributors as well. So let me share screen. Is that visible?
Yes, that works.
Okay.
Perfect.
I'll just wait until you give me the nod to start, and then I'll start the meeting.
Yeah. Ideally, I think I'd like Jawad to say a few words because he's been working with you, and thanks to his efforts and your efforts, you're able to present today. So,
Yes.
Jawad, whenever
Yes.
you.
So actually, this project was started by Bapi and Mike and folks in this particular effort. They are working on die-to-die testability, and their objective is to write a white paper that will eventually become a contribution by to OCP. So I had asked Mike to come here and show the work that they are doing and look for fellow travelers. So Mike, it's all yours.
Yes, please get started.
Okay, as Joe had mentioned, there's quite a few of us working on this, and we're looking for fellow travelers is a good way of saying it, but people who can join and give us some feedback. So I'll spend just up until the half hour, so another 25 minutes just going through this, get some comments, and then hopefully get some volunteers. So this isn't a full list of the contributors. You'll see the authors as we go through. The authors can put their name here or not. So there's more contributors. I would say there's probably at least another 3 contributors who haven't put their name to it yet. And that's their decision based on the confidentiality. Executive summit, I will write at the end, so you can see that I'm going to write that. But that will probably be written once we've got the document rather than too early. And similarly for some of these sections. Okay. So I know I have to fill this in to make it OCP or ODSA compliant. And again, that's something we plan to do at the end of the project. But what we're currently focusing on really is the content. So we've got a problem statement. What problem are we trying to solve here? We try to look at the current status of chiplet tests. It's very much focused on, say, chiplet test, building out to 2.3 and 3D. Okay, not necessarily focused on any particular interface. Not necessarily focused on a bunch of wires or UCIe. It tries to be more generic than focused down a particular interface. Obviously, we talk about DFT strategies. We did have a DFT expert. Unfortunately, that person hasn't been able to make any contributions. So we are a little bit, maybe a little bit light on the DFT area. We talk about how to accelerate the test. Some content on system level test as well, and functional tests. So this is an area which we see in the market a bit more. I should just say, I come from TestSolve, and TestSolve is a test service provider, as well as doing chip design. And I'm actually working on the chiplet at the moment with a UCIe interface. But we do a lot of work in test, and we do a lot of work in system level test, which is more around running functional tests rather than structural tests. We also do packaging and board design, and we actually did some work for ODSA and the BAPI, where we actually connected to, we did the interposer package design for multiple chips connected via a bunch of wires. We do a lot of embedded, but probably here the main focus is on the test. Known good design testing, and how we would try to improve yield based on KGD, and then looking at the cost of the test. First of all, wafer sort, and then some assembly and package testing, board level design, system testing, and trying to model the economics of all this, and comparing the costs as well of wafer die level testing, module package, the testing cost impact of high yield, and routine optimization. You can read this yourself. And DFT, obviously, then how we can use it, because we can do the DFT as for the structural testing down at the die level, but then how do we do DFT at the high level, at the where we've got multiple the chiplets connected on the interposer, and then how we're going to actually then run tests on that final assembly. So DFT will stretch all the way from the individual chiplets all the way up to the final assembly. Okay, the standards that are involved here, conclusion, glossary references, so what you'd expect.
Okay.
Yeah. So if you see any missing content, just let us know. But I'll skim through these, because I don't think at the moment we're looking for detailed feedback in this meeting. There's an online document where people can go in and make comments, so we'll share that. We'll share that link afterwards. As I say, the initial bit is mainly around. Hello. Was that a comment? No, maybe it's best people to go on mute if you're not talking. So here's the problem statement. As you can see, Madamita is a contributor from Synopsys. She hasn't put a name on the list of authors at the moment. And so she sets out what the problem is regarding multi-die packages, where one bad die can result in the failure of the whole package. She's trying, and this heterogeneous integration issues. So she's trying to set there what she sees as the challenges. So DFT, standards across the various chiplets, the architectural challenges, in order to be able to do hierarchical testing, where you've got multiple layers of hierarchy within the chiplets, and then the inter-chip communication functional test. So this opening section there is just trying to set out what is the problem we think we're trying to solve, and then we go into the current status of the chiplet test. So this has been written. The authors have taken their name off here, but this is Boon Chang is on the call. He's written a lot of this content, so he's on the call. And who else is on the call? Contributors. So Boon Chong, there you can see, is a major contributor. They're probably don't see anybody else at the moment. So we talk about the here, what we see as what we feel is the current status. So we talk about the standards there, and not only the standards here, but how we see the inter-die test going on. So once we've actually got the individual die tested, this is about how we would do the intra-die test and then the inter-die test as well, and the final package test. So all of those are obviously important. We talk about what we think the current status on that is. So scan traffic over native PCIe. This is a way of sharing the scan vectors for high-speed protocols, high-speed interfaces such as PCIe, USB. We've been doing some work on that around 1149.10 ourselves. So about how we can accelerate scan the vectors across those high-speed interfaces. Okay. And that's we're trying to capture this here. Obviously, then moving into 2.3 and 3D. In terms of what we see, the current status of how those are going to be tested. Known good die, near-term and long-term requirements for known good die. System level repair. Again, this is mainly a lot around yield recovery, so that how you can try to recover yield through, but by having additional, some repair activities, maybe some extra lanes on the high-speed interfaces, etc., etc. So, how you can actually then at the once you've got all the chiplets integrated, how you could potentially do some repair to get the yield recovery, and the diagnosis as well at that system level. Okay. And then as well as obviously testing the die, you need to test the interposer. Okay. So this is, you can see there's a lot of content here, a lot of very good content written by the various people. And that's where we see the current status. Okay. Again, we'd like to get some feedback on that. Probably best not to do it now because there's a lot of detail in here. And then, as I say, our DFT contributor has not contributed, but I think I don't know if Boon Chang wrote this or did James write this. I'm not quite sure. We've added something on a DFT here, the various DFT strategies that you need across the board. Okay.
So Mike,
Yeah.
quick question for you. So the goal of the white paper is to outline the existing issues with 2.5D and 3D
Yes.
testing, and then have some recommendations, I guess. Is that what the high level?
Yeah, so we yeah, and then the recommendations about how to do this. So we try to first of all state what we think the current status is, what we think the challenges are, and then we will set out where we think what the recommendations are, and within here there are good recommendations. So you can see they're sort of integrated here. This is maybe a I don't know if you see this section here as a recommendation, or is that strong enough to be a recommendation? Or so at the moment, what we suggest is the solution to these is embedded within the sections rather than pulled out as a separate set of recommendations. But it might be useful to get your feedback on that, and about how best to structure this. Again, you can restructure it based on how you feel would be good. But you can see here, there's a lot of recommendations are actually in line rather than pulled out as a separate section. Right. So here, it says what the challenge is about fault isolation, and then there's a suggestion there about how you may solve that. But I'm happy to take that as a restructuring request based on your feedback. And then accelerating tests. Some of these aren't new. Built-in self-test, for example, scan compression. We do a lot of work on SSN, for example, maybe appropriate there. But a lot of this is, for example, how you might want to do parallel testing, how you want to do the on-chip instrumentation and communication. So these techniques are reasonably well known, but then how do we actually put them together when you're trying to get across multiple chiplets in the final assembly? So again, there's a lot of content and recommendations about how that could be done. And new technique, well, I say new, but techniques such as SSN, which we're using. And then, so yeah, again, we go through various standards here. It's still quite a long document. And then we go through how we could be applying system level and functional tests and what advantages that would bring, and how it could be done, how it could complement or even replace some of the structural based testing. Okay. And then finally, the known good die tests and the assembly yield recovery, how that we could potentially do that. And I'll skip through that. And then, so at the moment, I would say it's mainly a collection of people. So then we go into test costs. There's a big section, very well written section on the cost of test as well, and again how you can possibly reduce that cost, and how you can model it and do your trade-offs. Okay, trade-offs across various test types. Okay, I'm just aware of the time because I want to allow for some discussions here. Okay.
So Mike, this is generally just talking about traditional scan and applying it to chiplets essentially, right? There's no, it doesn't,
Throughout the
it
paper,
doesn't,
there's, about how we could apply what are the extra challenges for chiplets and how would we adapt these techniques for chiplets. I mean,
yeah, but it's all
very
coming
long.
from a scan approach for a parallel interface. And I think it's fundamentally sort of weaker because of that, right? So,
Well, apart from the functional and the SL2.
yeah.
So I mean, in terms of your feedback, how would you suggest that could be improved then?
I don't know. I think that there should be something that talks about, hey, there's a lack of, when you assemble these devices and the common, I mean, Intel has published a bunch of information on, the defects they get and how what they've seen, right? So, and other people are doing the same. So how do you, run the test and then how do you do it at higher speed? Because I think scan is just, I just don't see how scan's really going to get everybody there.
So
That's just my personal feeling. But
there is
yeah,
a section,
yeah,
there is a
okay.
section
So
about
I was just going to say that just looking at what you've shown so far, it's like you put together all these scan generation tool guys and they're proposing, hey, let's just extend what they have, right? So that seems to be kind of what's everybody's proposing. That's just my impression.
yeah, but the scan is going across high-speed interfaces, not across the normal scan interface. But I understand what in terms of Intel.
Yeah, your idea of a high-speed interface is just sending the data through like a PCI Express bus, right, or something like that, right? So, or USB, not the actual die-to-die interface itself. I think that was my point.
Has there been any consideration of mutual testing of chiplets, where one chiplet helps test the other chiplet, kind of back and forth? Has that been looked at all?
Yeah, so there's some consideration about loopback, that sort of like a loopback test based on the die-to-die interface, you mean. So
And there's usually, and a lot of these, I think all the interfaces have redundant bumps, right? Are you taking into consideration how to map to out of redundant, or open circuits on bumps? Is that part of your scan or your test methodology here? Or to also identify if there needs to be a shift on the bits to jump over an open circuit?
So there was a section that I showed there on yield recovery about how you build in redundancy so are you talking about redundancy there being if a particular bump is not working, how you can then switch to a different interface signal? Is that what you're saying about through that yield recovery?
That is the case. Yeah. I think both UCIe and PHY have redundant bits in the bump map to be able to map them in if there's an open at any one other one, even maybe two other ends.
Yeah, so I think there is something now on redundant bits. On the scan, going back to the high-speed interface, I think we would suggest that we could I think there is a section that talks about how the scan vectors can be shared across the chiplet interconnect as well as the high-speed interfaces. So that you've got to get them probably on and off chip via the USB PCIe. I think once they're on the assembly, then sharing them via the chiplet interconnect is also covered. We've done a lot of work on 1149.10, how you can add in muxing a test controller onto those high-speed interfaces, so that and doing that on UCIe as well as PCIe, for example, isn't a huge jump for us. So certainly,
I'll just say, I mean, I think Nick kind of hit the nail on the head, right? So you've got these die-to-die interfaces, so you've got a chip across from you. First thing should be just to test that link works, and then you could then work backwards, right, to develop a test strategy. You guys are just saying, hey, just do JTAG, and it just, my intuition is that's, you know, unlikely to be very effective at really finding the problems. I mean, I think the link layer guys and the PHY guys need to sort of add more, perhaps more testability or whatever, but that's a different issue. But I think that you need to, at a subsystem level, when you've got 8 or 10 chiplets, which may be made by different people, you know, somehow there has to be some way of saying, okay, this die-to-die interface works with this die-to-die, and now how does it send data back to the system, and how can we drive all that and see where the issues are? Just doing scan, I'm not sure that it's going to
I'm not sure
be all that effective.
I think we're just
because the faults are going to be in the die-to-die, right? And there's going to be more than just, you know, people have talked about it's not just an open and short. It could be sort of a weak link or whatever, or performance link. So it really needs to be more, the approach has to be more chiplet oriented, the actual chiplet issues oriented, than just how do we apply scan vectors. I'll just leave my comments there. So
yeah, I'm not quite sure why you think we're only applying scan, but I'll take the feedback.
Yeah, so I think, you know, there's two pieces to it. One is to test the die-to-die interconnect. Yes, need to do that. The second is, if you got a lot of stuff on a chiplet, you need to test it. So, you know, full loop back testing, full speed, all of that has to go through the scan. So I don't know what the way around that is.
I mean,
I'm not saying not to use scan. I was just saying that you should be looking at it at a system level approach, just like a board level test where you have a, you know, JTAG that gets strung through all the IOs, and you can test level at the board level. You should be taking the same approach here. Now the package is a board, like a PC board, and you should be looking at it as a system rather than as a device.
Yeah, I thought that is covered, but
I see. Okay.
I thought that was covered in various places. Okay.
I mean, as an example, Mike, you know, you buy eight chiplets, right, from different people. How are you going to run the DFT, right? So you now have a design that's going to tie all these together. I mean, I'm giving you that as an example, right? So in your case, the DFT, you know, if you're designing an enclosed system, then DFT sort of makes sense from that standpoint. So somehow you have to already put in whatever's needed to test into the chiplets. So it's somehow there's got to be some standardization on that as well, right? Or some approach beyond just, hey, there's a JTAG interface. So I think there should be some thought put into that.
So regarding this, right, is IEEE 3405, this is just still in progress. For those that high interface related pattern.
You're a little bit.
Just highlight as a standard in progress. Other than that, it's more like you can have the direct test through those active interposals that you can have a mass switching test configured, which we highlight as the current solution.
It's a bit difficult to hear you.
Sorry, can you hear me?
Yeah, but you've got a lot of background noise.
Yeah, it's a little hard to hear you, Boon.
Oh, sorry,
Yes.
sorry.
Oh, it's better
I
now.
have my phone. I have my phone. The fan turned on. So the 3405 is a draft in progress. So we highlight it. So if it's more the direct test, then we highlight that there is a direct test where you just have the active interposers and then have a mark to control it. We highlight as a current solutions that are also feasible to test those interfaces.
So I just wanted to make a few comments. We have been for the last few years thinking about the multi-die test. And one of the things that we realized, the test community in the context of high bandwidth memory had actually developed a lot of that infrastructure that you see in these IEEE standards, but was very focused on some of that. And when you go to some new chiplet implementation, new ideas need to be thought through, but a lot of that appeared, we can reuse general concepts. So one of the idea behind this white paper was to get folks involved from various work streams, bring their ideas together. And if you notice, contributors of this white paper are mostly international. So the way we set it up was we said, okay, why don't we just work on the white paper instead of having work stream set meetings. So I know that this particular activity does have in-person meetings or like virtual meetings once in a while, but there's a lot of contribution or, the brain power that's coming together, and we need a little bit more than that. So my request will be, if you have interest in this topic, please join this particular work stream and maybe just add to the problem statement. I mean, it's okay to say, that some of this may appear trivial. It's just that in white paper, getting all of that knowledge in one location by itself is very educational, and it can help a lot of people. So that was the big goal of inviting Mike to this bigger meeting. So our call to action is, please attend some of their meetings, or just communicate by email and add to the white paper. The information about their activity is actually on our wiki page, or you can directly contact Mike.
I as I say, we got some good. I didn't catch the name of the person who was talking about the DFT strategy from different vendors. Who was that? I think
Maybe Cash, right?
who was it? Sorry.
I think Cash was asking the question, but yeah.
Cash and Nick, yeah.
Oh, Cash.
Moon was-
Cash.
But I have a comment. I mean, George, I mean, your point is well taken. I mean, having contributed to DFT sections for both business Workstream and the CDX, I didn't know this parallel effort. However, the problem which are raised by Cash as genuine, and I mean, the answer to that question is when you are designing a chiplet, we assume that entire DFT architecture is in place, and then we need to have a system level view. And actually, that's the topic there is to my heart, system level DFT, and that is actually falls in completely in sync with what we are talking about here. I mean, I would like to definitely talk with Mike later.
Yeah, that would be brilliant. Yeah.
Yeah.
Sounds like
Because-
a suggestion, but just Pendu can.
Because it's all these standardization is going to take, I mean, I'm right now one of the participants in 1687 standards. IEEE will take at least 5 to 6 years to get standardization basically ratified and published for industry. This actually OCP has so many good ideas that we can at least push to expedite that. That would be great.
Yeah, I'm glad, Rajesh, you mentioned that. One of the things that I was thinking, some of the work that you have done in CDX and business, maybe that can be brought over into this activity also.
Yeah.
Yeah,
that-
absolutely.
Yeah.
Because I see the test economics is what is a very going to be the key. And that is, I think, he wrote some paper on how it is going to affect the chiplet level, system level testing. Yeah, I can talk to you offline or Mike.
Yeah, perfect. Thank you. Yeah, and Cash, it would be useful to get your inputs. Offline as well. I think for this, we're targeting October as the final version, so we've got we've got time to try and pull this together. But I think we've had this meeting. This has been some useful feedback from Cash and Rajesh, and I'll speak to Rajesh to pull that together. And I take the point about the scan. We are trying to do scan across the high-speed interfaces and the die-to-die interfaces. That is covered in the paper. But I do take the point that putting together 8 chiplets from different vendors and trying to get an overall system DFT strategy is going to be very, very difficult. But I think as Rajesh just hinted at the moment, the standards aren't in place. So that might be a
Yeah, I mean, I think if you look at most of the chiplets being done, right, they may have, particularly larger ones, they have some sort of a NOC in there, right? So that a lot of data is flowing through that. The NOC in some way is connected to the die-to-die interface, the high-speed interfaces. So, something tied to the NOC or tying NOCs together in some way, in a standardized way to aid parallel testing at very high speed. I think that's a radically different approach than trying to shove everything through this parallel scan type approach. So somehow I think that, I mean, I don't know. I think the industry is very early days, but in general, if you want to test anything quickly and also resolve a lot of the issues, then that might be a sort of at least a call to action. And I think you need the NOC guys as part of this conversation, right? Because they're the ones sending data all across the chips, right? So first of all, in the individual chip, and then maybe through a mesh or whatever as the industry grows. So
yeah. Okay. Is there any more feedback? Otherwise, we've got some good feedback, and as I say, I'll follow up with Cash and Rajesh, and Joe and Andrew. If you've got any comments, it'd be useful. They say it's an online document, so I can easily add people onto that, so they can edit directly into that. Okay. But otherwise, I mean, it's useful feedback. This is what we're looking for. Okay. I can stop there, I think. Andrew, yeah.
Yep.
Okay,
Thanks, Mike. Appreciate it. And yes, more feedback is good to hash it out. And does everyone did you send the link out, or should everyone have access to this link, Mike?
I can send the link out with I'll send some notes, and I'll send the link with those notes, and then I think people just have to click on it. I think it will come to me to give them permission. So, and then I can give them. Okay.
Excellent. Thank you. This is good stuff. This most chiplet systems are probably vertical integration today, so no one cares too much. It's all a handshake between two guys. But I think this one when you're integrating different pieces from different vendors is when this becomes a bit of a pain in the rear. So
Yeah.
great to address it. Thank you.
Okay, thank you.
So I had two other items on the agenda today. One was, so we'll go through those real quickly. You know, we started this discussion on the a low speed die-to-die interface, somewhat bow-like, but not quite bow-like, a lot lighter. Cash was actually very instrumental in starting this effort, and I haven't been able to get the folks together again. It's been difficult. There's about 5 or 7 folks who've expressed quite a bit of interest from different organizations in looking at this. And I feel I've lost a little bit of momentum in not being able to get us all together. So since Cash is here in this meeting, Cash, how would you suggest? I've lost a little momentum here. I want to pick it up again.
Yeah, I think the Wednesday morning call is probably because they are.
I see.
But again, that's hard for a lot of people to reach. So I don't have a suggestion, frankly.
Yeah.
It's hard for me as well to make that meeting, but as I'm getting busier, it's hard to make all these meetings. So it's a tough one.
Is that a Wednesday 10 a.m. call? Is that the one, or is it a 9 a.m. call?
It's a 9 a.m. call with Alad and
I see.
Right, and also yeah. So that's sort of the one that covers basically the engineering part of the PHY, right? So it's PHY centric. So that would be the logical one, but again, 9 a.m. meetings on Wednesday, it seems like not a lot of people can make them. So
but you know what? If at least if Ilad's gonna be there, and even if 50% of the audience is there, I think it's quite a winner. Right now, I've been able to get like 1 person, and by the time people respond, those meeting slots get filled up. So
right.
So let me do this. Let me today send out email to the 6 or 7 folks who were there, have been on the last 1 or 2 calls, and at least we've been emailing each other, and ask if at least a few of them can join that 9 a.m. And I'll try to join next Wednesday's 9 a.m. call for sure. And we'll try to at least build some momentum there and come up with a plan of action on how to go about this.
Okay.
I feel we started off with a big bang, and then I let it fizzle out, I think, a little bit. So just rally the troops and see what the next point to get to. So
yeah, and then if that doesn't work for everybody, maybe they can suggest something, and we can invite Alad and Kevin. Have they both expressed interest in attending? So, but I think Kevin's on. So, you know, I know getting everybody on at the same time is a real challenge. So it is what it is.
That's right. Marek is here too. Marek had was part of those.
I think I can try to make the meetings work as well. And then maybe the other thing that we could do is just try to define items that need to get worked on and enable a little bit of a kind of an asynchronous working model aside, so that even the people that cannot make it, that we like keep them on emails and like maybe have like kind of a quick review specifically for this topic, so that it becomes easier for them to also contribute like offline by email or something else.
So to Kash's point, I would echo that. I think this is Kevin, sorry, that the BOW is the physical layer meeting where we discuss, you know, PHYs. So it seems like a logical place for this. But personally, running lower speed is not really in my interest area. So I think if a different time or place aligns with the people who are trying to do the lower speed, lower cost PHYs, then that's totally fine with me. It doesn't have to be scheduled around me for sure.
Okay. Thanks, Kevin. So let's target, seems like that's the best call, and whoever makes it great, we'll make a fresh start from there. Thanks, everyone. Next up on the agenda is the pre-DAC CDX work. So Jawad, all yours.
Oh, yeah, so it looks like none of the CDX guys joined, but I saw Cliff. Cliff had a meeting yesterday. Cliff, can you give us some update on?
Yes. Hey, everybody. We did get together with the CDX folk and had a chat about pulling together a workshop looking at what are the complexities for what I call the new silicon supply chain, the new workflows basically needed for chiplets, and inviting a wide range of folks to be part of it. We also are looking to approach JEDEC to see if they will work with us to co-sponsor it. It would be a virtual workshop organized somewhat similar to what Merrick just did for the business workstream. And we are thinking now that we would have it in the early part of June, just in advance of DAC, which is June 23rd to 27th, I think. And we are speaking on the 25th at DAC in the afternoon, I think. And so we would potentially also try to arrange some in-person event at DAC as a follow-on. So that's where we are. We have a current theme, which I guess nobody was here today, but maybe next week or in one of the very soon meetings, we can share that and get feedback on it, and move forward from there. So we're looking to start issuing invitations for people to speak in the next week or two, and start to build an audience after that. That's helpful, Jawad?
Oh, yeah, that's super helpful. So I think I've been trying to do outreach and there is positive response. I think your outreach has a really positive response. So we need to build the momentum because early June is not that far.
Exactly. We'll have to get going and organize it in the next few weeks. Probably a big push just after regional.
Yep.
Hey, as Cliff is here, could I just make one request, please? Just at the Wednesday call, there was a discussion about trying to merge or look at ways of leveraging either the link layer or some other layer or the PHY layer, whatever, UCI and Bo. And then Elad made the point that because of NDAs and whatever, we may not even be able to discuss that in public. So somehow there has to be some clarification or conversation with potentially the UCI guys just to say, hey, is there a way that we could have a conversation, I guess, right? So I just wanted to raise that. That was, I don't know if that feedback has come to some of the other people in the bunch of wires team to try and have a conversation. How would we even have a conversation about how we can look at bump maps or the link layer and different interfaces and so on? So, yeah.
Well, it is a thorny problem, Cash, I admit. There's some different thoughts about how we might go about that. Probably something we want to think about carefully. The good news is I think we're getting the potential to have good support from Intel for the workshop I just mentioned on around CDX and the silicon pipeline. And with that interaction, I was hoping to leverage that relationship, which is more with the foundry side, back into the UCI folks and see what we could do. I can also put out a couple other feelers, but maybe better for me to know a few more specifics. We can talk offline on that.
Okay, yeah. I mean, maybe Alad is the right person to talk to, so he can give you the specific or what he would like to do, and then we can have him.
Yeah, I
you
have to
drive
talk
that.
to, I have to talk to Alad on a couple things, so
Okay.
let me try to connect with him on that as well.
Thanks, Cliff. The other thing is, I think for next Friday, that is the 19th, we're gonna have to cancel the meeting. Both Javad and I are traveling. There's gonna be folks traveling to the OCP regional. And then there's also a NIST meeting Thursday and Friday of next week in the Bay Area. So next Friday's meeting is canceled. I'm not entirely certain about the 26th. We may have to cancel that one too, but we'll send a notice out about it. And then we've got a plan for the one on May 3rd, where we've got a new modularity work stream, and that the co-leads in that work stream will present. So that should be a really interesting meeting, May 3rd.
And maybe Anu, let's plan to have the CDX folk and myself, I'll be on the call too, and we can give an update on the plans for the virtual workshop that we were just talking about.
Okay, you want to do that on May 3rd, or because I think next 2 Fridays, everyone's going to be on a plane or some kind of transportation somewhere.
Exactly, May 3rd.
Okay, yeah, May 3rd sounds good. So May 3rd will be CDX workshop update, as well as the HPC chiplet modularity work stream presentation from the co-leads. That's all we have, Javad?
That's all what I had. Anybody else had any questions, comments, requests?
Just one more thing, maybe if I may, let everyone know that the LBL Experience Center is finally having its first event. I say finally because we had something planned for alongside of the Chiplet Summit, but had to delay that because of last minute travel requirements within the DOE. But we're now rescheduled for the 24th, that's the Monday, just during the week of DAC. And we will finally be holding our first inaugural event in the OCP Experience Center at LBL. So stay tuned for details on that as well.
Yes, there's so much going on, Cliff. It's actually head spinning amount of stuff going on. All good, just saying. Okay, so we call it a day then. So we will meet again, not the next Friday or the one after that, but May 3rd will be the next Friday we meet. Feel free to send Javad and me email for any other topics that you want to bring up. But if not, we will give you 6 minutes of your life back to you, as Bapi would say.
Thank you.
Thank you.
Thanks.
Thank you.
Thanks, everyone.